Here we are going to learn how to integrate four more trigonometric functions. That is tan x, cotx, secx, cosecx. So we have already learned how to integrate sine and cos. So in the list of six trigonometric ratio, the integrals that we do not know is tan x, cotx, secx, and cosecx. We are going to learn how to integrate that. Before we do that, there is one important thing to understand. If I differentiate log of a function, what will be its answer? When I differentiate log of a function, log x derivative is 1 by x. Log u derivative is 1 by u derivative of u. So 1 by f of x into derivative of f of x. So I'm going to write it like this. Derivative of log f of x is f dash x upon f of x. Now we have learned by definition of integration, we know that derivative of a is b, then integral of b dx is a. This is the definition of integration. So from here I can say, I can convert this into integration formula. Integral of the right hand side, f dash x upon f of x dx is log of modulus f of x. Why modulus? Because log of positive numbers only, log of only positive numbers are there. So because derivative of log f of x is f dash x upon f of x, I can say integral of f dash x dx is log of f of x plus c. I put modulus because log of only positive numbers are defined. So from this I can say, if I have a function in the denominator 1 plus x square, and the numerator is 2x. So what have you noticed? The denominator's derivative is numerator. Denominator's derivative is numerator. Then the integral is log of denominator. Here you may not put the modulus because it is 1 plus x square is always a positive term. 1 plus x square is always positive, so I have not written the modulus. Even if you put the modulus, it's okay. There's nothing problem about it. So what you need to check? If the denominator's derivative is numerator, I can directly write the answer as log of denominator. So this is a very easy method to learn, apply the formula. Let's see, integral of 1 plus cos x sin x in the numerator. So when I differentiate 1 plus cos x, I get minus sin x, but I have only sin x in the numerator. So what I can do? I can divide and multiply with a minus, or I can multiply inside and outside by a minus sign. And now I can write the answer directly. Denominator's derivative is numerator. So log of modulus 1 plus cos x plus c. Here also modulus is not necessary. The minus sign outside is over here. Log of denominator. Here also, even if you don't put the modulus, it's fine because 1 plus cos x is always a positive number. So you can write in this manner. Let us look at some more functions. Integral of 1 upon log x into x dx. So you know the derivative of log x is 1 upon x. So you can imagine this function to be 1 over x upon log x. Now you can see denominator's derivative is numerator. So I can write the answer as log of modulus log x plus c. Again, if I have a function of this kind, root of 1 minus x square into sine inverse x. So what I'm showing in this problem is you are likely to search for the derivative in the numerator, but the derivative will become in the denominator itself because log x derivative is 1 by x. X is in the denominator, so only it comes with the function. So you need to visualize this one's derivative is present over here. Same way, sine inverse x derivative is present over here. So you need to visualize it as 1 upon root 1 minus x square divided by sine inverse x dx. And now I can say denominator's derivative is numerator, therefore log of modulus sine inverse x plus c. So when can I apply this formula? Whenever the denominator's derivative is present in the numerator. There should not be any difference. There should not be a constant extra. There should not be any x extra. So you should have exactly the denominator's derivative is numerator. Then only we can write the integral as log of sine. Verify whether this answer is correct. How do you verify if the answer is correct? If I differentiate it, I should come back to this. What is log of log x derivative? 1 by log x into derivative of log x. So that is exactly that we have. Same way, if I differentiate log of sine inverse x, what will be my answer? 1 upon sine inverse x into derivative of sine inverse x. So exactly what we are having is the derivative of the function, hence the answer is log of denominator. Okay, let's have a look at one more question. 1 upon log of log x into log x into x dx. So which is the biggest function here? Log of log x. When I say biggest means more complicated function. If I find the derivative of this, what is log of log x derivative? 1 by log x into derivative of log x. So that is exactly I have over here. So I need to visualize it as 1 upon log x into 1 by x divided by log of log x. Now the denominator's derivative is matching with the numerator. Denominator's derivative is exactly what you have in the numerator. So what will be your answer? Log of modulus log of log x plus c. This is how we can reduce the functions. Let me come to what really I wanted to teach, that is the integral of tan x. So integral of tan x dx. How can we write tan x as a fraction? We can write as sin x upon cos x. Now derivative of cos x is minus sin x. So we are in short of a minus sign. Now it is matching. Denominator's derivative is numerator. Denominator's derivative is numerator. So minus log of cos x plus c. Now I would not like to have this minus here. So I take the minus as a power. So log of cos x the whole raised to minus 1. What did I apply? N log a is log a raised to n. Now I can write this as log of 1 over cos x. 1 over cos x is sec x. So here is my first formula. Integral of tan x is log sec x. I have always told you, tan x and sec x are the pairs. Whether you do the derivative, whether you do integration, always in sec, tan is there, tan and sec is there. So integral of tan x is log of sec x. Same way, integral of cot x. We can write it as cos x upon sin x. And this is perfectly matching. Derivative of denominator is numerator, perfectly matching. So your answer is log of modulus sin x plus c. So both the formulae we need to by heart and keep. Integral of tan x is log sec x. Integral of cot x is log sin x. Remember, tan, cot both have log. Even you will notice that sec x and tan x also will be having log. Integral of sec x dx. What I'll do is, I'll multiply numerator and denominator by sec x plus tan x. So I multiplied numerator by sec x plus tan x, denominator also by sec x plus tan x. Now let's have a thought about the derivative of the denominator. What is the derivative of denominator? Derivative of sec x is sec x tan x. And derivative of tan x is sec square x. So what is common here? So have you noticed that the denominator's derivative is perfectly the numerator? So denominator's derivative is numerators, therefore my answer is log of modulus sec x plus tan x plus c. So this is how we can find the integral of sec x. So what is the integral of sec x? Log sec x plus tan x. Again you can see sec mein tan hai, tan mein sec hai. So whenever you integrate or differentiate sec x, there will be always tan present in it. Similarly, I'm going to teach you how to integrate cosec x. So in cosec x, we multiply denominator and numerator by cosec x minus cot x. Now let's see what is the derivative of cosec x minus cot x. Derivative of cosec x minus cot x is derivative of cosec x minus cosec x cot x. Derivative of minus cot x plus cosec square x. If I take a cosec x common, I get cosec x minus cot x. That is exactly what I have in the numerator. So my answer will be log of modulus cosec x minus cot x plus c. which I can simplify further. Log of 1 upon sin x minus cos x upon sin x. This further can be simplified as log of 1 minus cos x upon sin x, which is equal to log of 2 sin square x by 2 divided by 1 minus cos theta's formula, 2 sin 2 theta's formula, 2 sin x by 2 cos x by 2. So here I applied 1 minus cos x formula, here I applied sin 2 theta's formula. And you will notice that this became log of tan x by 2. This is a very short formula, so we often use this formula. Instead of, you can use either this formula or this. You need to see whether angle you want to keep it in the same or you want to vary. Both the formula you need to know. Sometimes we use this according to our convenience, sometimes we use this according to the value of x. If x is something special angle where we can calculate it, then this is fine. If x by 2 is required, then we use this. So both formulae need to be learned. One important thing that you need to notice here is, here I divided and multiplied by cosec x minus cot x. Now your mind starts saying, why don't we do this way? Integral of 1 upon 1 plus x square. Why can't we do this? Derivative of 1 plus x square is 1 by 2x. Now, the problem, what mistake that I have done is, the variable x cannot be, a term with x cannot be removed outside. Only constant can be removed outside. So I cannot remove this x outside. I can take 2, but x cannot be taken. So that is a mistake. So I cannot do this method. Even if I write 1 by x over here, this derivative is matching, but this is not matching. So the method of applying this way of doing it is wrong. You cannot divide and multiply with an x term. You know that this is integral of tan inverse x. Integral of 1 upon 1 plus x square dx is tan inverse x. But you cannot divide and multiply and apply this technique. You can only divide and multiply with a constant term. You cannot divide and multiply by the x term. So do not think of doing this all the time, this dividing and multiplying. Here in this problem, you have noticed that after dividing and multiplying, the whole numerator became the derivative of denominator. That happens only in this problem. It doesn't happen everywhere. So if exactly the denominator's derivative comes in numerator, here there is an extra term. We are not able to adjust that extra term. Hence we cannot apply. Just like that, any function, divide and multiply method cannot be applied. We shall now learn how 4 formulae. We'll practice on 4 formulae and learn all possible problems on this 4 formulae. That is integral of tan x, cot x, sec x and cosec x. Integral of tan x, when you write, just recap, integral of tan x, log of sec x plus c. So you remember, if I want to integrate tan 2x, what would be my answer? It will be log of modulus sec 2x divided by 2 plus c. So you need to divide by coefficient of x. Suppose I ask you to integrate cot 3x plus 2. Remember, when tan, cot, sec, cosec has got log in it, don't forget log. It is log of, cot is cos upon sine, denominator is sine, sine of 3x plus 2 divided by 3 plus c. Whenever x is having a coefficient, you need to divide by 3. Again, integral of sec 4x dx. Integral of sec x is log sec x plus tan x. So it will be log of sec 4x plus tan 4x divided by 4 plus c. Integral of cosec 3x dx. What is the formula for integral of cosec? There are 2 formula. One formula is log of cosec 3x minus cot 3x upon 3 plus c. This is one formula. There is also another formula. Log of tan half of 3x. 3x by 2 plus c. Divided by the coefficient. Don't divide by 3 by 2. Divide only by 3. You need to divide by the coefficient of x. Whenever you have a doubt, just differentiate and see whether the answer is coming back to cosec 3x. That's a very important thing, because often we have doubt. Should I divide by 3 by 2 or should I divide by 3? You need to divide by the coefficient of x of the question and not the answer. Now let's have a look at this one. Integral of cos 2x upon sin x dx. This type of problem, I say angle part are different in both. Whenever the angle parts are different, the manipulation of the function is not possible. So the first and foremost thing is make the angle same. What is the angle of cos 2x? So you need to convert it to x. So cos 2 theta has got two formulae. One is 1 minus 2 sin square theta. Another is 2 cos square theta minus 1. Now you need to ask the question which I prefer. I have seen sin x here. So naturally if I express this also in sin, then my manipulation is possible. So 1 minus 2 sin square x divided by sin x dx. So we have got both the angles same. So whenever the angles are same, you need to first of all look at this both and say angles are not same. Angles are not same. They are different. So what you did then? You made the angle same. You made the angle to the same term. Once you make the angle same, then you can separate them. 1 upon sin x. Now minus 2 sin square x upon sin x. That became integral cosec x dx. Minus 2 integral sin x dx. One sin will get cancelled. So sin x dx. Now both of the formulae we know. We don't want to write a very big formula. So what I'm going to do, you can write in two ways. One method is you can write log of cosec x minus cotx. Minus 2 integral of sin x is minus cos x. So minus of minus plus cos x plus c. This is two ways you can write. You can also write this answer as log of tan x by 2 minus of minus plus 2 cos x plus c. Any one method, you don't have to write both the method. You can learn one of the formulae, but beginning you practice both the formulae because we need to know both of them. Integral sine of x plus alpha divided by sin x dx. Again you notice angles are different. Angle of sine is x plus alpha, whereas here the angle is x. So what should I do? To make the angle same, remember the variable of intersection is x. Dx if you have written, variable is x. So alpha is a constant. So you don't have to much worry about that alpha. Anyhow, to make the angle same, I expand sin a plus b's formula. Sin x cos alpha plus cos x sin alpha divided by sin x dx. Which formula did I apply? I applied sin of a plus b's formula. I'm not explaining it because everybody knows sin of a plus b formula. Now what I can do? I can separate them. Sin x cos alpha upon sin x plus cos x sin alpha upon sin x. Students, you need to remember this what I told you once upon a time. The denominator is a single term, then the separation is possible. If I had a 1 plus or some sign here, then separation would not be easy and you will not be able to do it. That's why we have to keep the whenever denominator term is single term, think of separating it by over an addition or over an subtraction. So one more term will get cancelled and I can say cos alpha is a constant because variable of differentiation is x. So cos alpha comes outside, integral 1 dx. When constant is removed outside, like it is like integral of phi dx. How do you integrate phi dx? Phi goes outside, integral 1 dx. And we write your answer as phi x. Same way, cos alpha into 1 integral, this will become x. Again, we have sin alpha a constant and cos x upon sin x is cot x dx. Now both the integral we know how to integrate 1, we know how to integrate cot x. So your answer is cos alpha into x plus sin alpha into cot is log of denominator. What is the denominator of cot x? It is cos x upon sin x. So sin x plus c. This will be your answer. Now let's have a look at if it is reverse. Let's say it is sin x upon sin of x plus alpha. Now do not think of expanding the denominator. If suppose we have a plus b upon c, we can write a by c plus b by c. But if you have c upon a plus b, you cannot write as c by a plus c by b. So by expanding the denominator, you will be in more problem because this such an operation cannot be done. This is wrong. So we are only allowed to expand the numerator. Denominator should always be a single term. So what to do? Here is my idea. I add an alpha and subtract an alpha. Addition of one alpha term and subtracting an alpha term. Now what I did before, I can apply the same method. Sin A minus B's formula. Only difference is sin of A minus B's formula. So sin A cos B minus cos A sin B divided by sin of x plus alpha dx. So I can now separate like last time. Sin of x plus alpha into cos alpha divided by sin of x plus alpha minus cos of x plus alpha into sin alpha divided by sin of x plus alpha. So cos alpha being a constant outside the integral, and they both will get cancelled. So 1 dx minus sin alpha outside the integral. Cos upon sin is cot x plus alpha into dx. So my answer is, final answer is cos alpha into x minus sin alpha into log of sin of x plus alpha plus c. This will be my final answer. Cot integral is log sin. Integral of 1 is x. Hence we get the answer. So if the denominator is having a plus sign, bring the same angle in the numerator. So you remember that my aim is to bring the same angle in the numerator, not in the denominator. Denominator, whatever is given, it should be kept as it is. So add one alpha and subtract one alpha. Let's try one more problem. Cos of x plus a divided by cos of x minus a. Both are entirely different. It is similar to what you did before. The denominator angle is x minus a. We are not allowed to manipulate the denominator angle. We can manipulate the numerator angle. So what I am going to do is, I am going to write this as cos of x minus a plus. Now I need to make it is equal to x plus 2a, x plus a. So you can see this, x plus a is nothing but x minus a plus 2a. Minus a plus 2a will give you a. It's balancing both the side. So I'll write a 2a here and I'll do exactly the same method what I did last problem. Now I can expand. It is cos of x minus a into cos 2a minus sin of x minus a into sin 2a divided by cos of x minus a. So one term like last time got cancelled, this and this will get cancelled. So it is cos 2a integral 1 dx minus, when you take it this way, sin 2a is a constant. So sin 2a is outside the integral. So just look at this, sin upon cos is tan. So it is tan of x minus a into dx. So this became cos 2a into x minus sin 2a into integral of tan. Integral of tan is log secx. So sec x minus a plus c becomes your answer. Let's have a look at one more problem. 1 upon sine of x minus alpha into sine of x minus beta. You can see that if I take the difference of this angle, it is beta minus alpha, because x will get cancelled, which is a constant. And I am allowed to divide and multiply with constant. So what should I do? If both the denominators are sine, we have two possibilities. Either denominator sine and cos, or we have a denominator that both are cos. Remember this. Whenever you have same trigonometric ratio, divide and multiply with sine of beta minus alpha. You can also divide and multiply with alpha minus beta, You need to check with your answer in the question in the textbook. If it is alpha minus beta, you need to write this as first and this as second. Then become alpha minus beta. So either you can divide with beta minus alpha or you can divide with alpha minus beta. I think I will put alpha minus beta. That will be better. If you are putting alpha minus beta, the numerator will be sine, okay, I'll write sine alpha minus beta divided by sine of x minus alpha into sine of x minus beta. Now this numerator sine, I will write it as sine of alpha minus beta. I'm going to write it as x minus beta minus x minus alpha. And then I will write sine of x minus alpha into x sine of x minus beta, which means you have two options here. One is you can write beta minus alpha. If you write beta minus alpha, you will write inside bracket as x minus alpha minus x minus beta. So anything you will do, and we do not know which is greater, whether alpha is greater or beta is greater. So any way it can be done, no problem. Now we'll expand sine of a minus b's formula. We can expand now sine of a minus b's formula to become sine x minus beta into cos x minus alpha minus cos x minus beta into sine of x minus alpha whole divided by sine of x minus alpha into sine of x minus beta. Here is the reason why we are using sine. If the denominators are same trigonometric ratio, when you expand, they should become opposite. If the denominators are sine and cos, the numerator should become same. Then only when you separate, one term will get cancelled. For example, this and this are getting cancelled when you separate this. And when you take this way, this and this will get cancelled. So one term should get cancelled. Then only we will be able to do. And further, after cancellation, the angle should be same. For example, when we cancel this both, the angle here x minus alpha, here is also x minus alpha. So we can combine. Same way, here when we cancel this two term, the angles left have same, so we can combine. So we have made such a way that we can combine them. So now let's see what happens when I separate. So when you separate them, you will get the answer 1 upon sine of alpha minus beta. So which term get cancelled? This get cancelled. What is left? This two term. Integral cos of x minus alpha divided by sine of x minus alpha. Then minus sign, integral. When you separate them, this both terms will get cancelled. What is left is this two. So cos of x minus beta divided by sine of x minus beta. So which I can write two ways. Denominator's derivative is numerator. So you don't have to make it into cot. Directly you can write the answer. Or you may make it into cot and use integral of cotx formula. I can write directly log of sine of x minus alpha and log of sine of x minus beta. Even if you make it into cot, the answer would remain the same. One extra step will be adding. And you can combine them. 1 upon sine is cosec. And you can combine log m minus log n. So log m upon n. So this way you can combine the both and write it as a single answer. This is the way we can get the answer for this. It's a very important question. Several times this question has come in the board examination. What happens when it is one is sine and other is cos? What to do in such case? Again, you notice that one angle is x minus alpha, other angle is x minus beta. No manipulation can be done if the angles are different. And you also notice that the difference between the angle is a constant, is alpha minus beta. So only difference between the previous problem and this is, if it is same trigonometric function in the denominator, you multiply with the sine, alpha minus beta. You remember S for S. When it is different, you need to multiply with cos of alpha minus beta. Then only the manipulation of separation will work. Otherwise, the manipulation of separation will not work. Cancellation will not work. You will not be able to integrate it. So you need to remember this. So cos of alpha minus beta divided by Same, I mean both should be the same trigonometric ratio. Here both are different trigonometric ratios, so we are multiplied with cos. And sine of x minus alpha into cos of x minus beta. So now I can write the numerator as cos of x minus beta minus x minus alpha. So sine of x minus alpha into cos of x minus beta. That became 1 upon cos of alpha minus beta. Now we can apply cos A cos B, cos of x minus beta into cos of x minus alpha plus sine of x minus beta into sine of x minus alpha. I expand sine cos A minus B's formula. Then I can separate them like the previous problem. Now remaining part of this problem remains exactly like the previous. You will notice that one term is getting cancelled here. Here cos x minus beta will get cancelled. Here sine x minus alpha will get cancelled. After cancellation both angles are same. So exactly like the previous one, this also works. So let's separate and see what is the answer happening here. So this became 1 upon cos is sec alpha minus beta into integral of, when you separate it, they both will get cancelled. So this will be remaining cos of x minus alpha in upon sine of x minus alpha plus, here when you separate x minus sine x minus alpha will get cancelled. You will be having sine of x minus beta divided by cos of x minus beta. So that became sec of alpha minus beta into integral of cot x minus alpha dx plus integral tan of x minus beta, or you may write directly log as answer. Anyway, since I have changed this, let's do it both the same way. Now my answer became sec of alpha minus beta into log of sine x minus alpha. Integral of tan is log sec, so log of sec alpha x minus beta. So finally, I can combine both the log and write as log of sine x minus alpha into sec x minus beta plus c. Log m plus log n is log m into n. If you don't like this pattern, you can change a little bit the pattern. You can write as sine of x minus alpha divided by cos of x minus beta. So this part, last part, you can write it anyhow. Or even you can do one more thing. You can divide and multiply with minus sign, denominator's derivative is numerator, and directly obtain this. So that is also possible. So it doesn't matter anyhow you do it. I wanted to teach you the formula for tan and cot, so I have used it.